Hi and welcome to this video about introduction to WMI. So what is WMI? WMI is short for Windows Management Instrumentation. It's a fairly old but still useful technology which is part of Windows. The basic idea of WMI is to provide a way to expose configuration and other kinds of information, even allowing us to perform operations in a uniform way, without having to use different APIs, but always using the same kind of APIs exposed by WMI. And WMI exposes its information using object-oriented way of thinking about it. There are namespaces that can contain sub-namespaces and classes. With classes, you have properties of those classes if they're representing some kind of singleton, but you can also create objects or have objects instances created based on classes as you typically would think of in object orientation. And of course, again, it makes sense for certain kinds of classes, but not all of them. And then every class can expose properties, methods, and even events, and they can be consumed using various APIs. The fundamental API is based on COM, that's how WMI is implemented. But there are wrappers that allow us to access WMI using scripting languages like Visual Basic Script or PowerShell, or some tools like WMI-C. And so typically people don't use the COM API, which is very verbose, but use something else entirely. In any case, WMI is implemented using a service called Win Management. You can find this service in, say, Task Manager, and it's hosted in a standard SVC host executable, just like most of the built-in Windows services. And in theory, that service there just listens to requests coming from anyone on the machine. And then when things have to be done or information has to be retrieved, it uses one of its worker processes called WMI PRVSE, where their number might be small or might be larger depending on the amount of WMI activity on the system. WMI, by the way, also supports DCOM, Distributed Component Object Model, which means that it's possible to invoke WMI stuff across the network. And this is very convenient for administrative purposes, which is one of the primary uses of WMI. An administrator can run a script on one machine that goes and does something on every machine in the domain. That makes it very useful and very easy to work with from that perspective. As I mentioned, the basic API is COM-based, based on the component object model, meaning there are a bunch of interfaces implementing by various objects provided by the WMI service. And as I said, in typical usage for most people, this is done using some kind of scripting language, such as PowerShell, which is probably the most common way of using WMI these days, but could also be done using other specialized tools. One tool is called WMI-C or WMI console, which was and still is used to invoke WMI stuff. So I want to show you a few things related to WMI in this video. So first, if I want to work with WMI, like I said, in order for me not to write any complex COM-based code, which is possible to do, but I don't think I'm going to show that to spare you. I'm going to launch PowerShell. Now notice that there's PowerShell, the Windows PowerShell, which is part of Windows and works only on Windows, but today there's also something called PowerShell Core. Now PowerShell Core is a cross-platform implementation of PowerShell, which is the thing that Microsoft mostly works on. So this thing runs on Mac and Linux as well, but it doesn't support everything that the Windows PowerShell supports, and one of the things that are not supported here is WMI. So if you try to do something like, say, get process, this returns the set of processes in the system. This works in PowerShell Core just like it does in Windows PowerShell, but all the WMI related commandlets just don't work. So if you see that you're using that and it doesn't really work, then you need the normal Windows PowerShell. You can get that using the terminal. It has all these things already built in, like the Windows PowerShell versus the PowerShell Core. And if not, you can just go ahead and right click here in the start button or use the Windows X and then launch a Windows PowerShell. You don't have to be an admin for most things, but in some cases you might want to be an admin for whatever you're trying to do. And so here's an example of what we can do. And if you're familiar with PowerShell, you know that we can get the list of processes in the system using get process commandlet. This is nothing new. It's been around for many years. And the question is, how does get process work? And there's really no way to tell without actually digging into the implementation. And we know how to enumerate processes. I've done multiple videos showing you various ways to enumerate processes, so it might not seem like a big deal. And I'm going to just pipe that into get member to see what kind of properties we can get for each process. So you can see that each process has lots of properties we can get, and using the PowerShell powers, so to speak, we can filter and sort and do those kinds of things that we might want to do in some kind of a real application or something we're trying to do. And I'm not going to show that because the focus here is not really PowerShell. But you can see there are many properties here we can look at. And so technically we could just pipe that to something like select and just select certain properties, or use the where object or the where alias here to say that I'd like only, let's say, the processes that have a certain property that I care about, like threads, say, and I want that to be greater than let's say 30, or maybe I want something like this. And so if I do things correctly, of course, if I don't do things correctly, then I'm going to get into some kind of mess. So in this case, this idea of threads didn't go very well. As you can see, it is not comparable, blah, blah. And that's because of the fact that behind the scenes .NET object and it's not really built correctly in terms of the actual class that represents these threads thing. It's a thread collection of sorts, and so that doesn't work very well. But maybe you can try something like count, so that's better. So now we see that that we get the information about process only when number of threads is greater than 30. So anyway, these are just normal stuff we can do with PowerShell. It depends on the commandlets we have. And then we can start working with WMI. And so one way to start to work with that is use get WMI object. So get WMI object allows us to get information about some kind of WMI object or class. For example, one of them is called win32_process. If I do that, we can see the list of all the processes again. This time the properties have just broken the list because it's too long. And for each process, it provides a set of properties. Now, if you compare that to what getProcess provides, these are not the same properties exactly. There are some differences, and that's because this is provided by WMI, by a class called win32_process. And I'll show you how to get this information. How do I know that this class even exists? But for now, let's just see what we can do with that. And since I am in PowerShell here, we can continue doing basically the same thing, that just like I did before. I can do something like where, and then maybe take the current item. That's the way to say that, and say name, let's say equal something like explorer.exe. So I want only those Explorer processes. So now I get only maybe 2 processes here. Each one of them is an Explorer process. So you can see that some of the properties make sense for a process like handle count and executable path, things like that. And then there's some weird looking properties which are part of the WMI infrastructure. So obviously there's these properties, but as I mentioned, WMI objects can also have methods and even raise events. So one thing I can do is maybe I can use a method on the win32process class to create a brand new process. In fact, you can do that. So there's invoke WMI method commandlet we can use. And again, we need to have a class here on which class we would like to invoke that method. And then we might need some other parameters here. It really depends on what we need to do. We can actually tab here with the dash to see what we can select. And obviously what I'd like to have is a particular method. So I need a name here. I'm going to use the method name create. How do I know there's a create method? I'll show you that later on, because WMI has full metadata, so it's possible to query the infrastructure of WMI and look at what actually is there, what kind of namespaces we have, what kind of classes, which properties they have, which methods they have, and even what parameters these methods require. And so I'm going to use the create method here. I'm going to start Notepad .exe, and of course I can provide the full path, and I can also provide arguments. All these things are possible to do. So once I do that, you notice that a notepad here comes up. Here's the notepad. So how do I know this notepad actually was created by my command? So obviously there are some hints here. We can see the process ID is 8840, and I can go here and look for notepad. And here is notepad with process ID 8840. So obviously this is the same notepad. But the other interesting thing here is if I go ahead and double click on that, we can see that the parent process here is a WMI PRV SE executable process and not something like a PowerShell or something. Even though I've invoked things using PowerShell, because the WMI method, it sends a request to the WMI service using the COM interfaces behind the scenes, and then that WMI service then gives a task or instruction to one of its workers, so to speak, one of these instances of the executable WMI PRV SE, and asks that instance to do the thing. That is, in this case, create the new process based on Notepad. We can also see that by looking at the tree view here that we see in Process Explorer. As an example, Notepad is a child of WMI PRV SE, which is a child of SVC host. So which SVC host is that? If we double click and look at the services, we can see here that we have a bunch of services here. In this case, DCOM launch is the one that's responsible for that. But this is not really super important, but just so you know, this is a DCOM launch service, which is the one that's responsible for launching these executables, but at the instruction of the WMI service. By the way, if we go to Task Manager, it's a bit easier to find it here. We can go to Services, we can find Win Management. So here's Win Management, that's the WMI service. It is in process 3676, so we can find that here as well. So 3676 or something. Here goes. So this is the SVC host that's supposed to be implementing the WMI service, and indeed it is. In fact, since it's hosted in a standard SVC host, the actual implementation is in a DLL, and this is where the DLL is under WMI BEM, which is short for something that's related to WMI. This is based on some kind of standard talking about the enterprise way to manage objects in some uniform way. This is what WMI is based upon, and WMI SVC is the actual implementation. And so this is just proving you that indeed the creation of Notepad here happened from WMI and not directly by PowerShell. PowerShell just sent the request by using the COM APIs behind the scenes that is done by this invoke WMI method commandlet, and we got that thing created. Now, the last thing I want to show is to give you a sense of how do I know that this Win32 process class even exists? How do I know it has a method called create? Where can we find all these properties, and what other classes might there be that might be very interesting to look at, work with them at runtime? If I want to get information about the system, like enumerating processes, we've seen we can do that with WMI, not just with those APIs that we've seen in other videos. So I've created a tool which is still very much work in progress, and you can find that in my old tools repository on my GitHub account. And the purpose of this WMI Explorer is to show the hierarchy and namespace and classes in WMI, and also provide the details of properties and methods, things like that. And I also want to add the ability to launch, well, not launch, but call methods and some other stuff that might be interesting to look at. So you can see there's a root namespace here. This is the kind of the beginning of WMI. You can see there are various classes here. These are all classes. Every time I click a class, we can see the list of properties and methods it has. In this particular example, this class deletion, CIM class deletion, whatever that may be, has only properties, and these are the properties. We can see their names and their types. That is what kind of values they store. So all these things relates to metadata, which does exist. We can always get to that. Now, You might be thinking there may be lots of things here. What am I supposed to be looking at? What is the perhaps most important or maybe interesting stuff? So that happens to be CIMv2. That's where the most of the stuff we're going to look at in a typical Windows system resides. So in fact, when I use Win32 process here in PowerShell, I didn't provide the namespace name. I didn't provide the full name of the class. And I didn't have to do that because this particular commandlet and the other commandlets assume CIMv2 as the root, like everything that's under here, which means that if I look at Win32 something, we can see there's lots of classes here. So for example, there's a Win32 account seed class here, which has these two properties, but at the bottom, in the bottom view, you can see actual instances. These are actual objects of that class, which we can create ourselves if we want to, or if we need to, but some are created automatically by the infrastructure based on the appropriate provider. So every time I change or I move to a different instance, the properties at the top are changing. Here's another example. We have another thing here called associated processor memory, whatever that may be. It doesn't really matter what that means at this point, but when we go to these instances, every time we switch, we get the appropriate properties. In this case, they're the same, but they don't, of course, have to be the same. In most cases, they won't be the same. Here's another example, Win32 battery. So this provides properties about my battery. So these are all the possible properties you can have. And there's even two methods here, set power state and reset. And there's one instance of a battery, which makes sense because my system has just one battery. Again, no big surprise here. But once I select that, we can see all the properties of the battery. Now, if you think about it, how can I get information about the battery in a different way without using WMI? So now I have to kind of scour the documentation, see how can I get information about a battery, or my battery here, the battery on the machine. And there probably is a way to get all that information, because at the end of the day, WMI here, the provider for the battery, somehow knows how to get this information. So it's always available in some other way potentially. By the way, it could be some undocumented way, which is we don't know exactly how to do, but even if we do know how to get to that information, this is much more difficult than querying WMI, because everything is here. We're using the same APIs behind the scenes, whether using C++ or .NET or PowerShell or whatever, using the same APIs, just querying different classes, different objects, and getting information in a very easy way without having to scour some specialized APIs, which might be very difficult to actually come across. Here's another example for the BIOS. So I have one BIOS, which of course makes sense. And these are some of the properties of my BIOS, properties provided by WMI. If you continue, there are many more like this. For example, we have things like COM classes. And so you're probably familiar with COM. I've talked about it a little bit from time to time. So you can see there are many instances, like 649 instances here. I think I might have some bugs in some of the things that I'm doing here in this tool. I have to actually do something about that. But here's classic COM classes. These are the classes that you're familiar with. You can see there are 8,627 of these objects representing COM classes. We can get some of the properties right here. There's no need to query the registry. Normally, to get this information, you would query the registry and then hunt the information by looking at certain subkeys that you need to know that exist and all that kind of stuff. Here, you don't have to do that. You just get everything ready to go. It's really, really very nice and very powerful. So you can get a lot of information using WMI. Of course, there are two caveats to that. The first one is the WMI service has to be running. This is normally the case, and some features in Windows sometimes depend on WMI, so actually stopping WMI service might risk some instability in Windows and certain features going away, so it's unlikely to be stopped on a typical system, but still something that needs to be said. WMI requires WMI service, which typically is running. The second thing to note is that WMI is not fast. it's relatively slow or slower compared to if you do things manually. Say if I want to get information about the registered COM classes, I would go to the registry using registry APIs. This is going to be faster normally than using WMI, because remember, WMI requires communication to the WMI service. Also, information is passed in a not in a kind of a type safe way, but mostly with strings and stuff like that. So obviously there's overhead for WMI. So it's not about speed, it's about getting information in a uniform and convenient manner. Continuing on with some other examples here, like we've seen, there's like computer system. I have one computer system, obviously, and some properties about that. We looked at processes. Let's find that. So here's 132. There's lots of stuff here, really treasure trove of information, like all my logical drives here, C, D, E, F, and I currently connected to my system. I get some details about that without having to query any special APIs, with even some methods here to work with. Of course, I can change properties. Some properties are read-only, some properties can be written to make changes. Continuing on with the process, I really want to get to that thing just to prove that what I've shown you, where we can find more details. So we can go ahead and continue scrolling or just typing there to find Win32 process as the previous example shown. Here's Win32 process, and now you can see for instances, these are all the instances of all the processes in the system. And the list of properties you see here are exactly the properties that we've seen in the output in PowerShell. And you can see there's a bunch of methods. One of them is create, which means we can use that to create a process. And you can see there are other methods here we can use. You might be wondering where are these properties we've seen that started with double underscore. It seems to be missing here. This is just because I'm trying to make things easier here in the output. Okay, so some things has gone berserk here in the tool, but we can go to view and then show a system properties, and then we'll get all these weird looking properties which are considered kind of properties that might appear in many objects, and they're trying to give us some generic information like the superclass, because there's kind of a support for inheritance of sorts, and the namespace it's part of, and so on. And so by default I'm not showing that, but if you want you can see that. So this is process. Here's another example for a processor. So my processor in the system has these particular properties. And so you can see the list of available classes is really long. It's not just in CIM v2, but also in other namespaces. There's a lot and lots of stuff that you can find here, a lot of information you can get, and a lot of changes you can actually do just by looking at what you have here. And the thing is that most of these things are just undocumented. They're not really explicitly documented. You can just play around with that. This might remind you of something similar, maybe similar in some extent, which is ETW, event tracing for Windows, which I also talked about in a different video, which also provides a way to get the schema or all the information for most of the events. WMI is different. It doesn't have the same goal as ETW, not at all, but it just gives you a sense that there's some similarity in terms of the uniformity of information. Here's Win32 thread, by the way, list of all the threads in the system. We have like 9,000 something objects right now, and every time I select one, we can get properties for this thread object. So it's nice that you can get all this information without having to go through special APIs, just using the same APIs. By the way, WMI supports something called a query, some kind of WQL or WMI, a query language, which is similar kind of to SQL, which allows you to find information using this kind of command, this kind of query, without actually having to find or look at particular class. You can do something more generic than that. So it's pretty sophisticated and very rich in information. So this is WMI Explore, still work in progress. There's some bugs there I have to deal with, and I want to also add the ability to invoke methods and do some other interesting things. But for now, you can play with the tool to get a sense of what you have. You can see there's lots of stuff to look at. And like I said, most of these things are just not documented. Here's the hardware namespace. Whatever that means, we can look at various things here. There's no documentation I'm aware of that talks about these things, but you can definitely play with that and see if you can find something that may be of interest. So that's the basics of WMI.